The thing, I am not an engineer, unlike I think everybody else here. But the theme that I want to play is the role of exploration and discovery in understanding what we need to do in terms of expanding beyond the Earth and what opportunities we may have out there. And so a little bit of the story I want to tell is how we got started with this, and that is exploring the gravity field of the moon, which is kind of an essentially scientific thing. I was a co-investigator of the Grail mission, which was a pair of spacecraft that flew over the surface of the moon. Eventually, we lowered the orbit to an average of less than 15 kilometers. And we did that in order to explore what was there. Are there ores? Could we see extra high densities? What is the structure of the moon underneath the surface? And as part of the Grail return, which was a wonderful collection of data on the moon's gravity field, good not only for science, but also we can navigate close to the surface of the moon now, which we could not do before. But we produced a precision gravity field of the moon. You can see a lot of craters, the circular structures on the surface of the moon. But one of the side benefits of this is, since we did get so close to the surface of the moon, we could investigate the smaller scale features, and a number of graduate students from the Aero Engineering Department, Loic Chapaz, Rohan Sood, worked with me on this, as well as some other professors in the department, to push the data as far as we could and see if we could detect deficits of gravity that we thought might represent lava tubes. We knew about the previous discovery from Selene of the lunar skylights, and as Dr. Hayarama already showed here, we were able to co-locate a gravity deficit with the Marius Hills skylight, and believe here, as well as in other places of the moon, we have gravity deficits that indicate very large underground structures that would be ideal for shielding against some of the major hazards on the surface of the moon. Lava tubes, as he already explained, form from the aftermath of lava feeder channels. We believe that lava eruption rates on the moon were much higher than anything on Earth, 3 billion years ago, and as a result may have produced lava tubes larger than anything on Earth. The low lunar gravity also allows very large openings to be stable on the moon that would not be stable on the Earth. Some of these gravity signatures, for example, this one here, represents an opening that may be 80 to 100 kilometers long, several kilometers wide, and a kilometer high. We could put all of the greater Chicago into this lava tube and have some room left over. So here could be the foundation for actually a civilization, not just an outpost on the surface of the moon. This finding was at least partially confirmed by Dr. Hayarama's work with his students on reinterpreting the Selene radar data to indicate that there may be openings below the surface. There are some things that don't quite agree. We find from the gravity deficit very large empty volumes. That has not been confirmed yet by Selene, but it may be, as we were discussing last night, that the system is not optimized for actually finding very large lava tubes. We need to go further. This is part of the lunar resource. Safety from hazards is a lunar resource, and we should explore it more deeply. Are these things stable? This is something that we have been working on and continue to work on. The stability of large lava tubes. Are such openings stable? We think they are. Both on Moon and Mars, these would be ideal habitats, a resource in terms of safety. And this may allow us in the future to find safe, comfortable living accommodations both on the Mars and on the Moon. One theme, though, that I want to end with is this is a case in which exploration for its own sake has found an important resource. I do not think that we understand the lunar resources that we have available in enough detail actually to talk about putting people on the surface of the moon. There are other possibilities. We think that perhaps inside large craters created by water-rich asteroids, there could be large volumes of rock down there that are hydrated. NASA has paid no attention to that so far. And there are many other opportunities for resources. I think we need to go back to the surface of the, or not surface of the moon, but back to orbiting the moon, as I'll talk about in the panel later, and look in more detail for what resources are down there. We have to be able, as many other panelists have emphasized, we have to be able to use local resources. We're never going to be able to cart all this stuff that we need up from the surface of the Earth. And that is a great need for further exploration. So I'll stop there. Thank you.
Can you hear me? So I've always envisioned like our inflatable habitat being like the construction trailer you see at a construction site where used as office, obviously living quarters for a construction crew. So in using a lava tube for a habitat, I've seen a couple different designs. I was curious what your recommendation would be. Either it's building a habitat within the lava tube or actually using the tube structure itself, isolating off like a section of it and pressurizing it. Would the walls need to be additionally treated in order to pressurize it?
Well, we'd like to know that more. First, if the lava tubes are as big as the gravity suggests, it would be, I think, far in the future to consider pressurizing lava tubes that big. We also don't want to pressurize to the point that they blow the top out. Right. And that's a problem actually with dome structures and other things. We need to consider that it isn't the weight of the structure so much on the moon, it's the pressure inside that is the limitation on construction. I think Dr. Hayarama at other meetings has talked about Japanese efforts to actually try pressurizing meter scale lava tubes. We have not done anything in the United States that I know of in that direction, but that would certainly be something that we need to think about more. If we can just pressurize something that's already there, it will be a great advantage. I think in the future, we need to consider not just the existing skylights as openings into the lava tubes, but we also need to consider how we can, do some tunneling and get down to them from other locations on the surface, which is Professor Bobbitt's expertise in doing tunneling, and how we might do that in low gravity and create habitats that are in the places we want them instead of just the places that nature has given us a few caves. But we're sort of like in the situation of cavemen 10,000 years ago. It's back to the caves for us now on the moon before we can do anything more of our own construction.
If I could add just, we've talked about large caves. Do we believe there are any of a smaller variety that we could use as a test site, maybe 10, 15 meters in diameter?
There may be, but we don't know. So one of the problems with the Grail gravity is we could only detect big lava tubes. We really need another mission, not gravity, because gravity is ambiguous. You don't know, for example, from Grail how far down these are. We just know there's a mass deficit. And the advantage of using gravity is it sees through everything, and the disadvantage of using gravity is it sees through everything. We need, and we have proposed a dedicated mission using something like the ground penetrating radar to really define these structures. But with the Grail data, in spite of all of the advantages we had, we really can't detect anything smaller than a kilometer in diameter.
for the question to you, for the question from you, 2 points. And the first is from our latest sounding data, the scale is a little bit smaller than suggested by the Melosh or Gray data. And from the analogs of the terrestrial lava tube, there are a lot of scale size. And perhaps the main one is the weight is 20 or 30 meter, but the small size are there. So that we can expect a smaller size, for example, from the large scale 1 kilometer size suggested by the Gray data, but from the 100 meter from the latest data, and perhaps 1 or 2 or 3 meter size. And the next point is from the analog the terrestrial lava tube 2, terrestrial lava tube, and the lava tube are formed by the big, very hot lavas. So the lava that melted the surface of the wall. And after the ceasing the volcanic activity, then the lava flow down or flow outside. Then the wall rapidly cool down. So the lavas cool down and glassified and coated sometime. So the such a glassified materials like seals, like glass. So I hope such a condition is very good for the keeping the air. My hope in a sense.
Right, that was my hope as well, that it's self-sealed, it's sealed the walls.
Well, it may partially self-shield it, but if you've been in lava tubes, they are wet inside. And one of the things Professor Hirama says, the lava starts hot, it cools down, the basalt contracts, and it cracks open up. But it may be easier to seal up a few narrow cracks and make it airtight than it is to build a new structure.
So this is one of the prerogatives of being the session panelists that they can add. So from a underground structures point of view, having smaller sizes if they are possible, and using some sort of inflatable structure that you can pressurize against the walls of the lava tubes. That would have huge advantages. One is that you increase the stability of the underground structures against, for example, meteorite impacts. The second is that the structure that you need to provide the pressure inside is going to be much smaller because you already have the reaction from the walls. And then you can have issues about loss of permeability of air if you don't with the membrane. The problem with that is that, and that's one of the things that our group is looking at, is that you need to be careful about this membrane getting against the big asperities. And then it may create issues of being punctured and so on and so forth. So that is an idea that we find interesting, and then we are kind of following up in this direction because we think that it has a lot of potential. And with this, now I'd like to thank the panelists for their insight and for sharing with us all those thoughts. So join me in thanking